Here is a function. We want to estimate the slope of the tangent line at x equals a. To do that, we move over some distance and find the slope of the line that passes through those 2 points. If we moved over some distance h, then the slope of this line is f of a plus h minus f of a over a plus h minus a, or f of a plus h minus f of a over h. We could have gotten a better approximation if our second point were closer to the original. The closer we are, the better. You should be able to guess what we're going to do. We're going to take a limit. This expression is the exact slope of the tangent line. How about an example? Find the equation of the tangent line of f of x equals 1 over x at x equals 2. Set up the limit, plug in the values, make common denominators, simplify, and take care of the double fraction. The h's cancel, now we can plug in h equals 0, and we get minus 1 over 4. But we're not actually done. The problem wanted the equation of the tangent line, which is this. You should be using point-slope form of a line. It makes this much easier. Do not use y equals mx plus b. It's more work and more opportunity to make a mistake. Math teachers like to have several different ways to say the same thing. We do this to be tricky. Here are several synonyms. Slope of the tangent line, f prime of a, the derivative at x equals a, instantaneous rate of change, marginal change, and there are many more. I could probably do this all day. Finally, one more example. If f of x equals x squared, find f prime of a for a equals minus 2, minus 1, 0, 1, and 2. You should pause the video. Work this out, it'll be fun. There most definitely isn't a shorter way to do these 5 different problems. Okay, there is a better way. Don't plug in the number when you compute f prime of a, leave it as a. It might seem far more confusing, but it's really the same work. If you get confused, try it with a few numbers and compare your work to mine. You should see similarities. Anyway, I find f prime of a equal to 2a. Then f prime of minus 2 is minus 4, f prime of minus 1 is minus 2, f prime of 0 is 0, f prime of 1 is 2, and f prime of 2 is 4. Let's draw this. Here's x squared. Notice if the derivative is negative, the function is getting smaller or decreasing. If the derivative is positive, the function is getting bigger or increasing. If the derivative is 0, it's flat. Finding where the derivative of a function is 0 will become a huge theme in this course. Even here where the derivative was 0, the function had a minimum, and you can imagine that finding minimums have a huge practical application.